All right, problem 3. We got these particles here, and we have they have masses of let's see, of Ma and Mb, and we need to find out where to place the third particle, particle C, with mass mc, so that the net force on particle A from B and C is 0. I believe that's what they want, right? So the net gravitational force on particle A from B and C is 0. Okay, so let's find out which way particle A is feeling a pull from B. So first of all, let's just find the direction. Which direction is going to go? Well, B is attracting A, right? Gravity always attracts, so A is going to feel a force FB from B, which is going to go that way. So let's see, FB is going to equal, so first let's find the magnitude, capital G, right, times Ma Mb over d squared. And then what's the direction of it? Well, it's being pulled in the positive x direction, right? B is going to try to attract A to it. So that's going to be I hat. Okay, so in order for C to neutralize that, basically the net force on A has to be 0, right? Which means that force B is acting on A, and then the force from C is going to act on A. Those are the only two forces we're going to have, and those have to equal 0. What does that mean? Well, it means that FC has to go that way, right? And in order for these to add up to 0, it has to have the same magnitude. So it's pretty easy then, I think, to see that the force on C has to equal negative capital G Ma Mb over d squared I hat. All right, well that's part of we're halfway there, right? So now we got to figure out where C has to be. Well, if C is going to be pulling A to the left, then obviously C has to be over here, right? So let's say C is over there. Let's say it has a distance. I don't know. What's a good letter? Let's use E. Okay, let's say E is the distance from A out to particle C. So particle C is out here on the x-axis, a distance E. Okay, so the magnitude, then we can find out what, for the mass of C and the mass of A, we can find out what the force of C would be for a given distance E, right? So force on C at this distance E is going to equal, and we just do basically the same thing we did here, except we compare the magnitudes. So actually, you know what, let's just say this is the force we know has to be coming from C, because this has to match the force on B. So we know from the fact that A has no net force on it that this is the force on C. Let's just take the magnitude of that, since we've already established direction, right? Nobody really cares anymore about direction. So FC, just the magnitude of this, is going to equal, now my hard drive is doing something. I'm probably going to have the audio desync. Sorry about that. G Ma Mb over d squared. Okay. Now, based on the position of C, what does the force on C, what's the magnitude of the force on C going to be? The force on A from C is what we're calculating here. So what's that going to be based on this position of C? Well, G, mass of A, mass of C, over E squared. Okay, so now we're getting there. So let's say these two have to be equal then, obviously, because they're both expressions for FC. So G Ma Mb over d squared equals G Ma Mc over E squared. Okay, and where that gets us is then E squared over d squared. I'm going to cross multiply to bring this up. So I'm sorry, I'm jumping ahead a little, because I've been thinking this in my head as I went along. But first we can cancel the G's, obviously, and then we can cancel the MA's. So we're left with MB, MC, D, and E. So I bring E up top, or the E squared up top, over D squared, and that's going to equal MC over MB. And that should be enough to give us our answer, right? Or we can do E over D equals MC over MB and take the square root. So I think that ought to be enough to solve this here, because they want us to give it in terms of a fraction of D. So we're going to take, let's see, so it's MC over MB, and then take the square root. So let's try that. So MC is 55 MA. Oops, square root. 55 MA, and MB is 3 MA, so square root of 55 over 3. And now remember, taking the square root, that can actually really be positive or negative. And in this case, what x coordinate are we looking for? Well, x goes positive that way, and we're going to go negative over here, so let's see, that should be negative 4.28. So let's see if that is right. 4.28. And that's 2, and there it is. Got it. So that's how you do problem 3.